Why are lipofuscin and melanolipofuscin in the retinal pigment epithelium toxic?
Incomplete phagocytosis or recycling of retinal in the RPE led to accumulation of undegradable bisretinoids and lipofuscin. Here you have an RPE cell in an electron micrograph from an 80-year-old woman, and we see that in the cytoplasm there are many lipofuscin granules. And in such RPE cells of aged people, up to 19% of the cell cytoplasma can be occupied by lipofuscin. Therefore, only by this space-consuming property, lipofuscin granules can inhibit RPE cell function. Here's a couple of publications that stated these findings in detail. Here we have a tangential section through the retinal pigment epithelium of a monkey. We see the normal hexagonal shape of RPE cells. We can recognize the lipofuscin granules by its whitish appearance, but there is one exception. One cell looks completely different. It has become round due to very high accumulation of lipofuscin. This is the nucleus here. And we have a hypertrophy of this RPE cell, and it is clear that such a cell cannot fulfill its normal barrier function because the tight junction of such a cell cannot close tight and separate the subretinal space from the choroid. And it would be great if lipofuscin removal will restore the original cell shape and function. Lipofuscin is the greatest risk factor for dry AMD and Stargardt's disease. It is located in lysosomes. It is not degradable, and it is not degradable end product of phagocytosis and or autophagy. The question whether it is removable or not is currently under discussion, but there is clear evidence that under certain conditions it can be removed. It has chosen progressive accumulation, and it is highly autofluorescent, as you can see here in this image. This is a paraffin section through the RPE cell from a 50-year-old man with normal vision. And what we see here is the amount of lipofuscin in the RPE cells under normal conditions. In old patients, we do not have only lipofuscin granules, as you can see here in an electron micrograph. We also have a high amount of so-called melanolipofuscin granules. These granules consist from the melanin core and the margin of lipofuscin. You can see it here. The origin of this lipofuscin is still unknown, so unbelievable it is, but it is the presence of lipofuscin is at greatest risk to get AMD or other age-related degenerative diseases. Lipofuscin photogenerates a range of reactive oxygen species. Among them are superoxide anion, singlet oxygen, hydroxyl radical, and lipid hydroperoxide. And this probably causes death of retinal pigment epithelial cells and finally geographic atrophy. This image shows the result of an experiment in which was investigated whether lipofuscin granules from eye donors can generate radicals. And here these Lipofuscin granules were isolated from donors of different age. Here we have in black people below 40 years, and in yellow we have people aged older than 80 years, and the other two are in between. And these lipofuscin granules were kept in a specific setup of experiments under which the formation of radicals can be analyzed by electron spin resonance spectroscopy after illumination. And it came out that the older the donors of the eye were, the higher were the ability to generate radicals. And this is a very interesting finding, because this shows clearly that lipofuscin from young people is different in the chemical composition than lipofuscin from old people. And this has not considered in science currently, but this should be of great importance. It should be of great interest to find out what the chemical nature may be behind this finding. Here we have another experiment. Again, isolated lipofuscin granules were used and were fed to human RPE cells in culture, and then these cells were illuminated for 84 hours, either with amber light or with blue light. And then it came out that these cells that were illuminated with blue light and fed with lipofuscin before died, and only around 30% survived after 48 hours. Cells that had been kept in the dark alone or were only fed with lipofuscin or were only in culture did not die. Here, with amber light, more or less nothing happened. This is a very important experiment which clearly shows that blue light induced probably radicals in these cells from lipofuscin that is able to kill the RPE cells. In conclusion, lipofuscin is a toxic product of lysosomal degradation and generates radicals and is space-consuming. In the future, understanding the role of melanolipofuscin will allow to develop new therapies. If you are interested in preclinical research, please visit our homepage. Thank you very much.